So, first of all, you have to make sure you have the hypotheses. If your hypotheses are not met, you don't use L'Hopital's rule. If, what does if mean? The hypotheses. If the limit of the numerator is 0 and the limit of the denominator is 0, use it. If the limit of the numerator is infinity and the limit of the denominator is infinity, use it. If the limit of the numerator is 0 and the limit of the denominator is 5, don't do it. But then 0 over 5 is what? Good. If the limit of the numerator is 10 and the limit of the denominator is infinity, don't use it. But when what's 10 over infinity?
0.
So here's an example. So this is the one they do in pre-calculus. The limit as x goes to infinity of 5x plus 2 divided by 3x plus 7. As x goes to infinity, this goes to
5/3.
infinity. Huh? 5 times infinity plus 3 is infinity. As x goes to infinity, this goes to infinity. Are the hypotheses satisfied?
Yes.
Yes. So L'Hopital's rule says take the derivative of this, take the derivative of this, and then take the limit. L'Hopital! What kind of limit? Infinity over infinity. It says take the derivative of this, what is it? 5. Take the derivative of this, what is it? And then take the limit. As x goes to infinity, 5/3 goes to
5/3.
5/3. So infinity over infinity, today at 1020 is 5/3. Sometimes you may have to do L'Hopital twice. Sometimes you may have to use L'Hopital twice. Here's another example. As x goes to infinity, this goes to
Infinity.
infinity. As x goes to infinity, this goes to? Huh?
Infinity.
So L'Hopital, infinity over infinity limit. L'Hopital, infinity over infinity. Okay, sorry, 8 over infinity is what?
0.
So I will take the derivative of this and divide by the derivative of this. But you must know what the derivative, I'm sorry. Divided by, and now take the limit. And what do you have? Lo and behold, you have the same thing. As x goes to infinity, this goes to. And as x goes to infinity, this goes to. So do it again. Again, infinity over infinity. What's the derivative of this? 10. What's the derivative of this?
12.
12. Infinity over infinity today at 10:22 a.m. is what? 5, 6. Okay. Let's do another one. The limit as x goes to infinity, your e to the x. You see now your pre-calculus friends will say, okay, that's not a rational function. You're going to have to help me out. So well, then I know some calculus. As x goes to infinity, e to the x goes to.
Infinity.
As x goes to infinity, x squared goes to. So this is L'Hopital's rule. Oh. What kind of limit is it? Infinity over infinity. So we say take the derivative of that and take the derivative of that, and then take the limit. What's the derivative of that?
E to the x.
E to the x. And what's the derivative of that? And then you say, well, now let's do it. As x goes to infinity, this goes to? As x goes to infinity, this goes to? Infinity. But they're both going to infinity. Do it again. Infinity over infinity. Take the derivative of this, what do you get? Yes. Take the derivative of this, you get 2. And now take the limit. As x goes to infinity, this goes to? Infinity. As x goes to infinity, this goes to? What is infinity divided by 2? Infinity. That is to say, this guy goes to infinity much faster than that. Not a contest. Okay. Not a contest. Let's do another one. Let's do a 0 over 0 one. As x goes to 0, this goes to?
0.
As x goes to 0, sine of 0 is?
0.
Minus 0 is?
0.
This is the worst kind of limit. 0 over 0. Mr. Boji, what is 0 over 0 today? We don't know. We have to do it. We say L'Hopital what rule?
0 over 0.
L'Hopital 0 over 0. So I would have to do what here? What is the derivative of this? 1. What's the derivative of this? And derivative of this? And now take the limit. As x goes to 0, this goes to? As x goes to 0, cosine of 0 is? 1 minus 1? 0 divided by 1? You are correct. Today, 0 over 0 is 0. Would you like to try it, Mr. Boji? There you go. Try these. Oh, this one is cosine x minus 1. This one I write as a fraction. How do you write this as a fraction?
X over e to the
X over e to the x. Really should say L'Hopital's rule for indeterminate limits. That is 0 over 0, or infinity over infinity. If you want to know what indeterminate means, you can ask Mr. Boji. He will tell you. What's the first one, Mr. Collins?
Zero.
0. Second one?